me, Mommy. I'm flying. I'm flying, Mommy.
Oh, hi! Do you ever wonder how airplanes stay in the air? I mean, there's no roads up there for them to drive on, and we all know that if you drive a car off a cliff, it certainly doesn't fly. And if that's true, how come airplanes can't fly to space? I mean, space shuttles fly to space. How do they get there? I just can't seem to figure it out. Whoa! What are you?
Oh, dude, I'm a cloud, man.
Wow!
Like a cloud.
Where did you come from?
Oh, I thrashed some serious waves, dude. You know, like using air pressure.
Really?
And just surf, dude.
It's all about air pressure? What does that mean for flying to space?
Huh?
Let's find out.
Folks, here I am with a new device called the ornithopter. This device, I expect to attain flight in the air. Through a system of leverage advantage, plus a man's physical power, I believe it's possible to fly as a bird. And here I am, you can look this device over. It appears heavy, it's light.
Oh, dear.
Humanity's been interested in flight for a very long time. The ancient Egyptians had a god called Saqqara, which was a bird-like object used for flight. Some conspiracy theorists believe it was built by aliens who came down to also help them create the pyramids. I'm not so sure about that. The Greeks had a god called Aether, or what we would say today, ether, which is all of the upper atmosphere, and it was the air the gods breathed. The Romans had Jupiter, the god of the sky. The Native American peoples used to worship the raven, and is on the top of many of the totem poles. We think that most gods throughout civilization have been faced upward with the sky. We've always pointed there. But we switched from a mythological idea to a practical one with the help of a guy named Leonardo da Vinci.
This is my helicopter. Doom de 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 doom. De doom de doom de doom de doom de doom de doom. De doom de doom de doom de doom de doom de doom. De doom de doom de doom de doom de doom de doom. Even though I tried, I could not figure out how to build this helicopter. I just drew it. But it's for you. Why do I sound like Dracula?
Da Vinci's ideas were revolutionary. I mean, he came up with a helicopter almost 600 years before it was actually invented. The problem in Da Vinci's time was the technology just didn't exist to really figure out how to get a human off the ground for any prolonged period of time. Now, around Da Vinci's time, people were thinking about flight, and it was a guy named Daniel Bernoulli who came onto the scene that really set the stage for human flight. You see, what he did was he took Leonardo's ideas and he put them into a mathematical theory. And his theory isn't that difficult. Well, in today's standard it isn't, but back then it was revolutionary as well. And his idea is like this. When you take a big deep breath in and you blow out, if you keep your mouth open like this, you can produce a pretty good chunk of air coming out, right? It has some decent force. You can test it by putting your hand in front of your face. You'll notice that it's very warm because your lungs produce warm, moist air. The thing that Daniel Bernoulli realized that if you were to do the same experiment, but this time instead of breathing out with your mouth wide open, you breathe out like you're puckering up to kiss someone. You'll notice a significant difference here. Did you notice anything? Yeah, it turns out when you do the pucker method, the air shoots, or the carbon dioxide, or your breath shoots out of your mouth much quicker. What Daniel Bernoulli realized in mathematical terms was the differences in air pressure can create a force called lift. And lift is the main reason why ginormous jumbo jets can get off the ground what appears to look very easily.
Today I looked at the sky. I looked at the birds. And I decided that I must find out how they fly. There must be mathematics behind their flight. And I believe I figured it out. About air pressure. Perhaps someday it might be useful to someone. Do you think? I am always curious as to why myself and my friends in the science field have such amazing hair. Could someone answer me that, please?
Once we had Bernoulli's ideas figured out, all we had to do then was compare them with Newton's laws of motion, and we wouldn't have any trouble figuring out how to build an airplane. Of course, you need that whole technology piece, but we'll get to that a little later. Have you ever been in your car, driving along, and you roll down the window on a summer day, and you stick your arm out? Do you know what happens? Yeah, your arm flies back. I mean, most of you are strong enough to keep your arm nice and straight. Next time this happens, I want you to do one simple thing. Raise your arm up slightly, and you'll notice something really cool. Essentially, it's Bernoulli's principle at work, married up with Newton's ideas. As air flows underneath, your arm elevates, or you create lift. So what we needed to know now was Newton's idea of force in action. For example, if we were to get something moving very quickly, and we put the wings on them, and we pointed them slightly up, we'd be able to create lift. This is what happens with a paper airplane. If you make a paper airplane that's really thin and thick like this, you can actually zip through the air much quicker. We call it aerodynamics, or fluid dynamics, if you want to get into the idea of water as well. Putting some force behind your plane is the equivalent of a motor or an engine on an airplane. And that was really the difference between us not being able to fly and us being able to soar the skies, almost to space.
When we take a close-up look at a jumbo jet in flight, we can see how Bernoulli's principle works. You see, lift is in a constant battle with gravity. Lift wants to raise the plane up, but gravity wants to pull it down. You see, gravity is a combination of the plane's mass and the force affecting it. Heavier things have a stronger gravitational pull. More importantly, if you have a heavy mass, you have to overcome that gravitational force in order to create lift. So instead of trying to make planes lighter, we make the engines bigger. And that engine allows the wind speed to pick up, creating thrust, the forward motion of a plane. All of this is impeded by drag, which is just the simple fact of going through air molecules. We've all experienced this while we run through a windstorm, and you can feel that wind pushing back on you. All that wind is air. So imagine doing that at 800 kilometers an hour or faster. It becomes extremely difficult to overcome. Luckily, in today's world, with the speed of our engines, we're able to do it. Do you want to see the Bernoulli principle in work without any flight? Check out this plane. It's actually starting to fly, even though it's on the ground. Because those wings are slightly pointed upwards, as soon as the air gets under it, it creates a difference in pressure, causing lift. So wind and wings can create lift. They actually had to tie these planes down, or indeed, they would have flown away.
We still haven't answered the question, can airplanes fly to space? Well, if you've been paying attention, you notice we've talked an awful lot about one substance, air. And unfortunately, the higher you go, the less air there is. Air's held down by pressure and gravity connected to the Earth. The higher you go, the more power you need to stay because there's less air to actually move through. Galactic Virgin was the first company to really create a hybrid rocket/plane. And this plane launched up into the air, and it was using 2 stages. And as you see in the video, it's got one important thing that most planes don't, or the planes we ride on. Rockets. Yes, rockets are the secret to get to outer space. You see, when there's no air, we need more power. We need more thrust to generate. because we can't get the lift that we could with a jumbo jet on the surface of the Earth. So the higher we go, the less practicality planes are. But some people believe this company's idea might be the future. Maybe one day planes will soar up high, almost into space, and then reach their destination on Earth much quicker. And what I'm going to leave with you today is, why is it then that airplanes often say we're flying at 30,000 feet, even though there's less air up there? See if you can figure that one out. Thanks again for watching.